Hey, Algebra 2, today we talked about the focus and the directrix. The focus and the directrix are important for parabolas because basically there's an equidistant value of p anywhere on a parabola's curve. So like the distance from here to here is the same as here to here. And so this directrix line and this focus fall right perfectly in between what we call the vertex, that turnaround point on a quadratic. So this distance p is the same either up from that vertex if you have one that's facing up or down for the directrix. And you can really use this idea of this formula a equals 1 over 4p to figure out that a value in a quadratic, whether it's in standard form or if it's in what we call vertex form. It's the same idea, okay? So we practiced today the idea of how to identify where the focus would be and where the directrix would be based on starting at the vertex, using that a value with the formula to kind of figure out p's distance and then going from there. Or sometimes maybe you're given the focus and the directrix and you have to find that point that's in the middle called the vertex and then use that to build your vertex form. So everything's kind of running together. Like I said today, this lesson's kind of difficult. It was difficult for me when I was learning it. It was even difficult the first few years that I was teaching it. So hopefully we're getting this idea down after we do some homework and a little more practice. Remember, our first test on this will be on Friday. Second test overall, but this will be our Module 2 test. Okay, so I think now that I'm looking a little bit closer about what I printed, and it had kind of what to do when we got to this problem here. Okay, the fact that you're given x equals is kind of a different style of problem, and so I didn't really mean to give you that for homework. So what I'm going to do is I'm going to change this problem a little bit. So y equals negative 1/4 x squared. So the letters were kind of flipped. And that's a totally different type of graph that we're not doing yet. And so we're just going to flip them, and I apologize about that. Anybody that doesn't do this one, don't worry about it, but I'm just going to flip them and kind of keep working with what we got. So when we're starting this vertex form, you don't really have anything in parentheses. So it's not going left or right. You're not really adding or subtracting anything in the back. So that means that we are living right in the origin, 0, 0. Remember, I just changed the problem. Okay, I just switched these because this is a totally different style of problem. I should have been paying closer attention to what I did. All right, so what we have now is we've got to figure out where is everything. So there's a formula, 1 over 4p. We're going to actually take that a value and replace it for a. And so this is going to help us figure out where the focus is and where the directrix is and all that good stuff. So I'm going to cross multiply. I get negative 4p equals 4. And I divide by negative 4 and I get p equals negative 1. So what that means is I need to go down 1 for the focus. And so my focus point is going to be 0, negative 1. Well, that means on the opposite side of it, equidistant and going up 1 is my directrix line. Okay? So my directrix line is equidistant from that vertex, and we're going to focus it in the down direction. So like I was saying, we can use a graphing calculator to type in the equation, and it can help us figure out where everything is. So negative 1/4 x squared. And let's go to the table, and I'm looking for a good point. I see 4, negative 4. I also see 6, negative 6. 4, negative 4, 6, negative 6. Okay, so it's kind of bending. Actually, I think I messed that up. That second point is 6, negative 9. My fault. 6, negative 9. Thought that looked kind of odd. It's supposed to be quadratic. All right, so let's figure out on the other side of that where we have good points. 0, 0 is our vertex. So there's negative 4, negative 4, and maybe you could have guessed it was negative 6, negative 9.
Mark Miller, please come to the main office. Mark Miller, come to the office.
There we go. Should be a mirror. All right, very good. So that is facing down, and we have a directrix line of y equals positive 1. And I'll make sure I got everything that's asking for. Got it all. We got the vertex, we got P, we got the focus, and we even have the directrix. Directrix is y equals 1. Okay, so let's talk about another one. And thank goodness this one's not as, doesn't need changing. I think probably is, hopefully probably one more. Yeah, one more I'll probably have to change. So we'll talk about those maybe later. So we're going left 2 and down 4, and that's to identify the vertex point. The vertex point is -2, -4. So let's go left 2 and down 4. All right, so same idea. We have this formula which helps us identify what the distance will be for the next point. And so I'm going to say that this is -1 over 8, and that value is this value in the front. So let's cross multiply and see what we get. 4p times -1, -4p. 8 times 1 is 8. And let's divide by -4 to figure out that, again, it is negative. So we're going to go down 2 for our new focus point. And that point is -2, -6. Our focus point is -2, -6. Well, if that p-value is -2, then we could go above that 2, and that would be our directrix line. Y equals -2. Remember that the focus is a line equation for a horizontal line, and then the focus is a point that should be inside the curve, because that kind of focuses the parabola towards a certain direction, whether it's positive or negative. So let's plug this one into our y equals and see what that gives us. -1 divide 8. It looks like we have x plus 2 squared, and then we're going down 4, so -4. All right, so we can kind of expect this type of graph, but let's get some good points using our table here. -6 makes -6. That's one point we can do. Left 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6. And a little trick, I can tell you where the next one's going to be. 1, 2, 3, 4, like 4 over here. I can go 4 more, so 1, 2, 3, 4. Because there's this symmetry going on. When there's symmetry, it allows you to kind of figure out where the next point will be, and you can be a little more intuitive. So this is really the point 2, -6, and so I'm just going to make sure that that's one of our points, 2, -6. It sure is right there. And now we can connect our parabola. This is called compression when it's wider like that, and that's because you have a fraction that is less than 1. You can kind of ignore the negative there. Any value, when you consider like the absolute value of that, that's less than 1, between 0 and 1, you know it's going to make it wider ultimately. Okay? So again, I feel awful. If you skip the ones that have this and you didn't watch the video, which obviously you're watching the video, so I'm not talking to you about it, but we'll have to talk about these later. It's a totally different type of graph when you have to solve back for y equals. So for right now, I'm just changing the variables to make it something that we are familiar with, because I didn't realize that I'd made it that way. So get rid of that positive, it's really, get rid of that negative, it's really positive. So here we go. So again, it's at the origin, because there's no parentheses telling us to go left or right. There's no value in the back telling us to go up or down. And so let's go ahead and think about this. A equals 1 over 4p. A is 1/12. So let's cross multiply and see what we get for p. 4p times 1. 12 times 1. So that's called cross multiplication. When you're solving for a fraction that equals another fraction. And let's divide by 4. And you get 12 divided by 4, 30. So that means that the distance up to the focus or the distance down to the directrix is the same, and that distance is 3. So let's go up 3. There's our focus point. Our focus is at 0, 3. And let's talk about the directrix next. The directrix is a line that is equidistant from the vertex, just like it's equidistant from the focus point. So let's go down 3, and that's going to make a horizontal line, and that would make it y equals -3. Y equals -3. So now let's use our graphing calculator to type in this equation that I changed again. It's kind of difficult the way it sits since we haven't had any instruction on how to do that. I'm not going to do that to you today, so let's just keep them the way they have been. Let's go to second table, and I'm looking for good points other than 0, 0. It looks like one of them is -6, 3, and I bet the other one is +6, 3. And that has more to do with symmetry than anything. So 6, 3, and then also -6, 3. And then this is compression because it's so wide. Very good. All right. So next, let's talk about one that has a focus at 0, 1. Write an equation in vertex form with the following focus or directrix for the following problems. And then it says, real importantly, assume 0, 0 as the vertex. 0, 0 is the vertex. So 0, 0 is our vertex. And then 0, 1 is our focus, okay? Our directrix is going to have to be right here because it's that equidistance idea, okay? So I want to figure out that my directrix has to be y equals -1 because if the focus is 1 above the origin, which is our vertex here, let's go down 1, and that's where our directrix line should be. Okay, so that distance that we've been talking about, which we call P, that distance is 1. Okay, P is a distance of 1. So see, we can plug that into our formula, 1 over 4P, 1 over 4 times 1, which is essentially 1/4. So if we need to write an equation for the parabola, which is what it says that it wants us to do, vertex form, you have that parentheses normally, but if it's at the origin, you don't have to worry about it. So this is 1/4 x squared. Let's try a directrix of y equals 3. So if it's at the origin, this is where our focus is, or sorry, this is where our vertex is, sorry, based on the directions in the top. If the directrix is up at 3, okay, then that means that our focus has to be on the opposite side, and that means that if this is a distance of 3, then we need to go another distance of 3 to figure out where that is, and that point for the focus is 0, -3. Alright, so now we're going to use the fact that that's a distance of 3, either here or here, because what we can do is we can plug that into our formula. A equals 1 over 4P. A equals 1 over 4 times 3, or 1/12. Okay? However, that distance is really negative because if you notice, my directrix is on top. I should really not mark it here. Let me think about it a little harder as a student with you. Because the directrix is up here, that means this point right here is the focus. So that means that my P is really negative. And you can really kind of recover if you understand that this is facing down because it's got to be towards the focus. That means your equation has to be like -1/12 x squared. Okay? It's focusing down somehow. And so we can use our calculator to graph that if we need to, but I think we're going to move on. Okay, guys, I'm actually going to take off 7, and I'm also going to take off 8 because it does hit more of the other type of problem, which I don't really want to do since we didn't have any instruction on it. Basically, in a lot of these problems, the parabola is turned sideways when you have something like this. And so it's not something that we've talked about. So look, all we had to do tonight was number 6, number 5, number 4, 3, and 2. I changed a few of those. Hopefully that's something that you all caught. We'll talk about this tomorrow. Thank you for watching the video, and I'll talk to you later. See you.